let's talk about arrays, specifically 1D arrays. So what is an array? Well, an array is a data structure and it's also an object. And we'll learn a little bit more about objects, specifically objects that we create, in a few chapters from now. But right now, we can just think of an array as a cubby, like back in kindergarten, where we kept all of our stuff. But this particular type of cubby holds a series of values. Now, the thing is about an array is that it can only hold like types, so it can only hold data that is of the same type. You can't mix types. So what types of values can an array hold? Well, you can hold integers in an array. You can also store doubles in an array. You can also store objects like strings in an array. Basically, you can hold anything: integers, doubles, booleans, which are our primitives, and objects like strings. But remember, a given array can only hold one type of value. No mixing types. So let's learn about how we can declare an array. So if we look at the basic form here, first we have to specify the types, so either a primitive type like double, int, or a boolean, or a specific object type by specifying its class name like string. Then we put these two square brackets to indicate that it is an array. And then finally you give the name that you want to call the array. In other words, its identifier. So this is what you choose. It's completely arbitrary and up to you, but usually we like to name our arrays with respect to what sort of things they hold. And then don't forget your semicolon. So here's an example of using this format to declare an array. So here we've declared an int type array, so it's going to be an array that holds integers, and it has a specific name chosen by the programmer called scores, so you can guess that this integer array is going to store things that represent scores. Now right here is a little diagram of what this looks like in memory. So basically, when you declare an array, you create a holder for the array's reference. You don't actually have an array yet. So if you don't initialize an array itself, that is, you forget to actually create the cubbies to store stuff in, the identifier is going to give you a null value. And null means that there's basically a lack of a reference. There's no array to which scores refers to, which is completely true right now. Scores does not refer to any kind of array because we haven't initialized one yet. We've just kind of put a placeholder for it. So how do you actually initialize an array? Well, here's the basic format. You have to identify the array by giving the name, and then on the right-hand side of the equal sign, we will put the keyword new, which creates a new object, and then we have to specify the type, or the type meaning the primitive or object type that the array can hold, and then in between the little brackets, the square brackets, we have to indicate how many slots or cubbies in the array. So how many values do you want to hold in the array? So here's an example using our previous example, scores. So we've already declared scores in the previous slide, so now we're initializing it. So we're saying that scores gets a new integer array that basically has 4 cubbies, so 4 slots. So now we take a look at the representation in memory. So just like we started when we declared the scores array, we have a little placeholder, but now it actually refers to an array with 4 different spots. Now notice it's filled with zeros. That's because when we initialize an array and we don't provide it with any values, the values take on the default value of whatever the type the array is storing. So the default value of an integer that is declared but not initialized is 0. And then to jog your memory, here's the rest of them in this table. So the ones that we're worried about are integers, which take on the default value of 0, doubles, which take on the default value of 0.0, booleans take on the default value of false, And then strings and other objects, like arrays, take on the default value of null, unless you provided a value. Let's talk about accessing elements in an array. So it's awesome that we can store all of these values all in one place. We want to be able to access them, and so each of the values that is stored in an array is given an index position, and it starts at 0. So when you want to refer to an actual element or value in an array, you do so by specifying its identifier and then its position or its index value. And you do that in between two square braces. So the name of the array and then its index position. So if we look at our example of our scores array, which has a length of 4 different values, each filled with zeros, you can see on the bottom there, those are the corresponding index positions. So it starts at 0 and then increases by 1 from left to right. So if we wanted to access the 0th element of the scores array, we would refer to it as scores sub 0. And the sub, S-U-B, is just the language we use to refer to this notation. So whenever you see an array and then referring to its index number, you say whatever the name of the array is, sub, and then its position number. So we could go through scores sub 0, scores sub 1, scores sub 2, and then finally at the final position, we could refer to that final element as scores sub 3. We can also find the length of an array by referring to the array itself dot length. Notice that length is not a method. There's no parentheses at the end of it. It's actually a variable that's specified in the Java standard library where arrays are actually defined. So here's our scores array. So if we were to write scores.length, that would actually refer to the integer value 4 because there's 4 different spots, 4 different cubbies in this array. Okay, let's go back to initializing the elements of an array. Right now we kind of haven't done anything super useful. We've just initialized an array to default values. But what if we actually want to put in some desired values? We don't want just all zeros for our integer array. We don't want all 0.0s for our array of doubles, etc. Well, there's a few different ways we can go through and access the different positions of an array to rewrite or insert a value that we actually want. So let's simulate some code. So here we go declaring the list of nums, and here's its representation in memory. So it creates that little placeholder for the reference of this array that does not yet exist. So here we go, we now initialize list of nums, and we initialize it as a new integer array with a length of 4. So we give it 4 different cubbies that hold the default values of integers, which are zeros. Okay, but we don't want an array filled with all zeros. We want some values for whatever our purposes are. We want to store some specific values. So then we specify specifying the index values of each of the little cubby holes or elements in the array. We can give it specific values. So I can specify a list of nums sub 0 gets the value 5, and so that 0th element gets replaced by the value of 5. And then I want to say list of nums sub 1 gets the value of 10, so that replaces that first element. List of nums sub 2 gets 15, so that replaces that value. And then finally list of nums sub 3 gets 20, replaces that final value. So here's a little bit more sophisticated way of doing the same thing using a for loop. So same thing, we're going to go ahead and declare the integer array list of nums, creates the placeholder, then we go ahead and initialize it as a new integer array with 4 different slots. And I'm going to use a variable x in order to calculate the different values I want to replace those zeros with. So I'm going to go ahead and initialize that integer as with the value of 5. So here's my for loop. And in the for loop, I'm going to go from I equals 0 all the way up to, but not including the length of list of nums. So I here is actually representing the index value of this array, list of nums. So remember, the index values start at 0 and go all the way to the end of the array from left to right. So I want the values 0, 1, 2, and 3, but I don't quite want to reach 4, which is the same thing as the length of the array. So you can always think of the last value, the last index value of an array being equivalent to its length minus 1. So that's why we go up to, but not including the length. And each time we're going to iterate through, we're going to add 1 to that index integer that I have called I here. Okay, so every time this statement here, I is less than list of nums.length is true, we're going to replace whatever value is at the index that we're at with the current value of x. Okay, so if we go ahead and we start this process, I is going to be 0, so we're going to go ahead and go to list of nums sub 0, so that's this first position right here, and we're going to give it the value, the current value of x, which is 5. So this first 0 should turn into 5. And we can kind of see a pattern here because x, each time this iterates through, increases by 5. So we can imagine that this is going to be 5, 10, 15, and 20, which it should be. So let's go ahead and check that a little bit. So as soon as we enter the value of 5 here, we see that x is increased by 5. This is shorthand for x equals x plus 5. So now x is 10. We go back up. I gets increased by 1. So I is 1. So when we evaluate this statement here, 1 is less than 4, the length of the array. That's true. So we go down here and we say list of nums sub 1, the second value right here, gets the current value of x, which is 10. So we see that reflected here. Now x becomes 15 here because it's increased by 5. And then again, I gets increased by 1. So now when we evaluate this, we say that 2 is less than 4, which is true. So list of nums sub 2 gets the value of 15. Again, x is increased by 5 one more time, so now it's 20. I is increased to 3, and 3 is still less than 4. So now list of nums sub 3 gets the value of 20. X does increase one more time, 25, but now when we increase I by 1, I is 4. 4 is no longer less than 4, so we actually exit out of the for loop, and we're left with this array being changed to reflect our previous array, 5, 10, 15, and 20. Now this is going to be a super simplified way of doing this, and it's going to create the exact same array, and the reason why you would use this method over any of the other methods is if you already have a list of values. You're not depending on any calculations to create the different values that are going to be stored in the array. So this is going to look super simple now. So you're actually declaring your array and initializing it at the same time. So you completely skip the part where you fill an array with zeros. You just automatically initialize and populate that array with the values that you feed in this list. And it's very important that you remember that the list is presented within curly braces here, and each element in the list gets separated by a comma. And then also the length of this particular array will be determined by the number of elements in this list. So since the list has 4 different elements, the array will be set up so that it has a length of 4.